And the test, as I said, is later. So we're doing some application work, just the one example today. This is sort of, you can do most examples of this example here. Have you got, who does biology? Do you guys do decay equations on decay, things like that, Perry? Yeah, a little bit. Do you talk about half-lives? What's a half-life, Perry? Okay, okay. The definition of a half-life, Perry. You're right, that's okay. Anyone else want to? Excellent, good. The time it takes for 50% or half of it to decay. So I'm not sure if this is scientifically correct. This is just an example. So we've got radium, got 500 years. It has decayed to 80.5% of its original mass. You're after the half-life. We want to find the half-life. Okay? So the half-life, we're looking, what sort of unit are we after? Years. After years. It's the time. This is time. So it basically looks like this. We've got that. It looks like a lot of gibberish, but can someone try and make sense of what this is? We've got an A naught, got a 2 in there, we've got time in there, and a K. Would anyone like to guess how it's all coming together here? Maya. Good. Okay. Thank you, Maya. A represents our substance, the amount that we have. As Maya said, A naught is our initial, what you started off with. So if we start counting a substance, it has to start there. In the same way things are growing, you've got to start with something for it to grow. You can't grow zero. You need an initial amount all the time. This just represents how much of it at any time. Can anyone tell me what is the significance of the two? Excellent, Zach. I'll give you a lolly for that later. A 2 to the power of a negative. Remember, if it's 2 to the power of negative 1, what are we really doing? As Zach said, we're dividing by 2. Dividing it once. But if I want to divide it by twice, I divide it by twice again. Divide it by 3 times. Like so. What's a shorter way of writing this? 1 over 2 what? Cubed. We're halving it 3 times. So here is our 2, but it's a negative because it's a decay. Because that negative power means we're dividing by the 2 each time. And so how many times you want to divide something is being controlled by the time and a factor k, which we'll get into, now. Any questions so far? So a lot of science in this one. Finally, now going to rub off. I've got 500 years. Where am I going to put that, Jesse? 500 years at time. Okay. Is there any information in regards to saying what K is here? There isn't. How do you relate an 80.5% of its original mass in here? What am I going to do? How am I going to change this equation? So I've got some sort of 80.5% in there. Where do I put it? What do I need to rewrite it? We've done as much as we can here, but over here we need to change stuff. Do we know the original amount? Manny?
The original amount? No.
No. So we've got to leave it unknown. Alright. How can I re-express our amount that we want to calculate in terms of the original amount? What can we do to our current amount? Our current amount is 80.5% of the original amount.
80 minus 19.5%.
Yeah, you could do that. You could do that. I'll show you a quick way, Manny. I think we could. Okay. So we're going to do, first of all, let's just change this into a decimal. 80.5% is now 0.805. So our current amount is 0.805 of the original amount. Can you see what we did there? We've got rid of an unknown, the A, and now we've got two original amounts here. What is the goal when we're trying to eliminate things? Is there anything that we can eliminate here already? It's like a puzzle. Yes, Zach. A naught. How are you going to eliminate it? Not minus. We're dividing as well. Get your calculators out as well. A naught is gone. 0.805. Now, using your knowledge of logs and exponentials, our current unknown is a k. What is a really good idea for us to do to this equation? How do I transform this so that we're pulling down the branch of k? Remember, it's like a tree. K's up here, we're picking the apple, I want to pull it down so that we can work with it. What needs to happen here? Who remembers from last week? If I bring a negative 500k power down, what do I write on the other side? Yes, Perry. It is a log 2. Good, Perry. Okay. And the very last step, if I want to get k by itself, can everyone now type in log 2, 0.805. What do we do to our log? Divide by negative 500. Thank you, Tim. Give me a rough, tell me what your calculator says, people.
So that's 6, but I think it's wrong.
6 what?
6.26.
Yep, 2588.
Yeah.
And then what do you have at the end?
E minus 4.
E minus 4. Who knows what that means? E minus 4 on your calculator.
So I thought the calculator was just shutting down whenever.
No, it's correct.
This sounds a good notation.
It is.
Times 10 to the negative 4.
Correct. So this, when you see an E does not mean error.
Which means times 10.
It means times 10. It's very negative 4. And when I times 10 to the power negative 4, am I moving this decimal place left or right if it's a negative 4? Left. We're making things smaller because it's a negative. So I go smaller 4 times. 1, 2, 3, 4. You are left with 0.000062588. It's a really small number. Let's, just for working out sake, we're going to round it off on our paper. But when you have a CAS, are you going to round it off? You're not going to round it off. You're going to keep the whole value in there. Very important. Okay. So we've got our K. Have we answered the question?
Yeah. Yeah.
What's the question?
Long's the half-life.
How long's the half-life? Always keep that in perspective. But we found something. We found a K. So it's because you probably missed last class.
Yeah, that must be why. Yeah, I was there last class. I saw
All right.
This is such a step up from chapter 9.
Okay, let's find half-life. Let's go back to the drawing board. Half-life. On the half-life, what am I going to do to the original amount? I'm going to half the original amount. Okay, that's what we're going to use. So over here, you can see, I might just, like what we did before, let's just start, I'll just write these steps in so we can see what we're going on. This will make sense in a second. I think it's best if we start here. It's similar to what we've got over here when we found K. Now, we started off with that, but we're replacing out the amount that we want with a half-life. Are we okay with that? Like we did before, what's going to happen to the A zeros? Cancel out. And then we have this. Okay? But we found our K from before. But I'm not going to write it in yet because it's a few decimal places. Okay, we'll write it up at the end. The very last step is this. Once again, we've got things in the branches that we want. What is the fruit that we're trying to pick here?
Half-life
Yeah, what exactly?
of the amount of years.
The amount of T. Yeah, what does that look like in the equation, Manny? What's in the branch?
Oh, T.
It's T. We're focused on T now. Here we're focused on K to get us rolling. Now we're using what we've got from K to also get T. So if I want to pull this down, all right, if negative KT gets pulled down, what is it on the other side, Emily? I'm pulling down our fruit. Thank you. Okay, you've got to get used to that transformation there. All right. So if we go now, if I want to get T by itself, what do I have to get rid of, Zaid?
The negative k.
The negative k. The negative k. And you've got everything now that you need because we know what a k is. It's this from before. Do not use the rounded off version. So now what you can do in your CAS, log base 2 of half divided by a negative of k, but use the answer from before. Copy and paste it into there. If you got it right, if you think you got it right, tell me what you get.
Is it 1,597?
No. Unless I'm wrong.
I literally just copied it.
Does everyone go to different answer? So it'd be log 2 half over negative 0.00063. Does anyone have something different?
What did you guys say?
I got 158.
What? There's a half-life.
Yeah.
It makes no sense. So if it's 500 years and it's only 20% of its life.
Okay.
Or maybe
Did anyone else get
maybe
158?
once it gets to its half-life,
Okay, so
it decelerates.
I'm going to double check that, but this is what's happening with radium from 500 years. After 500 years, the sample of radium has decayed to. So 500 years, it's now 80.5% of the original amount. But at 158 years is when it got half of its original amount. Things don't. This is not linear, people. This is not linear. So there's different rates here that's happening. This is an exponential. Okay. So from 0 to 158, it's half. Hang on. I hope that's right. I know. I'm trying to connect two different things. The maths is all right. They're both right, but we're trying to connect two different concepts.
After 500 years,
Yeah.